This is a homegrown problem, and I'd like to see what you think about it. We're talking about solutions in the set of integers, and again, I'm sure most of you know this, but the integers are just the positive natural numbers, negative natural numbers, and zero. All right, I'll just write it out though. This double ellipse form is, you see it sometimes. Zero is an integer. Zero is not a natural number in a lot of cases. There's some debate on that, or it's just a convention though. Okay, so that's the set of integers. All right, and we're given a quadratic expression, and we compose it with itself. Okay, and we get this statement right here, which relates back to the b in the original quadratic. Again, this is an operation of composition or compose, some people say. But again, we're supposed to find b and c. Now, I left out an immense amount of simplification. I don't think anybody wants to see all of that. But f of x means exactly what it says. It means place f of x everywhere you see an x in the original expression. So, see, x, you had x squared here, so you put f of x squared. And the same thing right here. You have x right there, so this is f of x. All right. So it's a function. It's an input to itself, so to speak. That's what composition does for you. Now, again, most of the work that I left out is right here. A lot of work, when you expand this out, it's a trinomial. You get some similar like terms. But this is what you end up with right here, folks. And I double and triple check this, okay? I don't think you want to see me go through squaring this out, collecting like terms and all that. So this is what f of x is actually equal to. You know, these statements right here. But we're given that also that f of x is equal to this statement that has some concrete constants in it. So you see, we can equate coefficients, which is what I do right here on the very next line. And you guys can verify I'm just equating the corresponding coefficients. Notice that b squared plus b plus 2c is the coefficient of x squared right here, but 50 is the coefficient of x squared right here, and that's why we equated, all right? And similar for the other three statements. Now let me number these just so there won't be any. We'll call this one number 1 right here, equation 1. This is equation 1. This is equation 2. And this guy right down here is equation 3. Okay. Now, again, I left out a little bit, but I wrote down what I did. The difference of the first two equations eliminates b squared. You see how b squared will get eliminated if you subtract the first equation from the second equation. So this is that result, folks. If you subtract the first equation from the second equation, you'll get 2's. You divide by 2 and you get this statement here. Again, you guys can verify, but I have double checked this, okay? So we get BC is equal to this statement. Why is that important? Because we can substitute it right here. You see this BC that we got from subtracting the first two equations results in BC is equal to this, okay? And so we can actually substitute it right here, okay? And that's what I did on this very next line. See how c squared BC became BC minus 25. B plus c minus 25. And y'all, when you simplify all this, you actually get something in quadratic form. C squared plus 2c is equal to 10 minus b. This is a little unsettling because you have two unknowns. You have two unknowns, but it turns out there's a nice way to work with it because of some constraints that you'll see down here. Now what I did right here is I just completed the square again. I'll leave out the details, but you got an extra 1 here because c plus 1 squared is equal to c squared plus 2c plus 1, but you have to subtract that 1, so to speak. Okay, so anyway, that's where the 11 comes from. And so we end up with this statement right here. Now notice that for this statement right here to make sense, it's 11 minus b, so b can't be any greater than 11, right? B can't be any greater than 11, but 11 minus b, since this is a square root operator right here, 11 minus b has to equal to the only three squares, you see, 1 squared, 2 squared, 3 squared right there. 11b has to equal to that in order for this to be evaluate to an integer, right? And so what that does, and I'll just write this out on the next line, you can just go through and check out the possibilities. Sorry. That also implies, this statement right here would imply that b must equal to 10, right? 7 and 2. 10, 7, and 2. Y'all, again, that weird thing there is supposed to be 10. Okay. 11 minus 10 gives you the 1. 11 minus 7 gives you the 4. And 11 minus 2 gives you the 9, right? So b has to take on the value of 10, 7, or 2. That's nice. Those are the only possible values for b, and that's already an immense restriction, okay? So let's go ahead and write down the possibilities here. I'll do it like this. B, comma, C. Okay, and I'll just write it cross horizontally here. 10, 0 is a possibility. And I'm not going to say, I'll delimit by commas here. 10, 0, 10, negative 2, and you guys can verify, but again, this has been double checked multiple times. I didn't get it right the first time. I was making quite a few arithmetic mistakes. Now, so we're done with the tens, right? We're done with the tens right here. So what about the next one? You get, let me write smaller so I can keep it on the same line. 7, 1, and 7, negative 3. All right. Now again, y'all, these are just BC ordered pairs. And then 2, 2. And finally 2, negative 4. So these are our only possibilities now. And so that's kind of nice, you know, even though we have only one equation and two unknowns, the restrictions owing to the bounding character of the radical here. You see that it kind of led to a nice bounding condition. All right, a very nice bounding condition. 6 possibilities. Now, what do we do with these? Well, we have to check. Now, this top one looks like a good place to check. You can tell that if you put a 10 right here for b squared, there's no way you're going to get 50, right? No way at all. Okay. With the possible, if you put a 10 here and then a 0 right here, right? So we can X this one out. I'll just put X next to that, right? It doesn't work. Okay, now in a similar fashion, if you put 10 for B, it's too big without even doing the computation, right? Okay, now look, if you put 7 there, you get 49 plus 1 is 50, but then plus 2 times 1, that would be 52, right? So 7 and 1 is close, right? Only counts in hand grenades and war, right? Or horseshoes, is that it? Okay, so 7, 1, you go 49, 49 plus 7 is 56, plus 2 is 58, right? Okay, so how about 7 and 3? Well, if you put 7 and 3 here, I'll go ahead and put it right here. 7 squared plus 7 minus 6, right? You see there, folks, because that is a minus 3 there, right? Okay, that does equal to the 50, so we'll put a check mark next to this one, right? And it's very easy to verify that 2, 2, and 2, negative 4 don't work, so I'll X those out. So yeah, that's it. That's our answer right there. BC, this is the answer. And let me just come up here and write it. B equals 7, C equals negative 3. Okay. B is equal to 7, and C is equal to negative 3. Just like that, folks. Put the comma there. And that's the answer, folks. I thought it was kind of a nice problem. Again, it's a homemade problem. I was trying to do something else, work with some of the roots and vietas. I couldn't come up with anything, so I just turned it into another problem. Just redefine the problem so I could use the work I already did. I was trying to do the relationship, but between the sum and the product of the zeros and all that, and the pairwise products of the zeros, all the elementary symmetric polynomial stuff. But I couldn't get it to work out. I couldn't get anything to work there. So I turned it into something that's hopefully marginally a challenge, because it looks like this problem's tough at the beginning, right? Because there's only a few constants present, right? But you know that B, 2B, and then B right here, a connection between function and then this composition of the function with itself, okay? And so I think that's it, folks. I think 7, -3 is the only answer. Let me know if you see any mistakes.